Hi everyone, this is me again, Teacher Christine, and in this video, we will try to find the area of a segment. And before we will try to find the area of a segment, I assume that you already saw or watched the video about how to find the area of a sector. For us to easily solve the area of a segment if we already know how to find the area of a sector. And in finding the area of a segment, we have this formula. Area of a segment is equal to area of a sector minus area of a triangle. And ma'am, what is the area of a segment, by the way? So let me try to explain to you or illustrate to you what is the area of a segment, or where can we find the area of a segment. So if this is our figure, the area of a segment, your class, is this one, or the shaded part, this one. The area of a segment is the difference of the area of a sector. This is the area of a sector, diba? This one, the area of a sector is this one. This one whole. This whole minus area of a triangle. If we will subtract area of a sector minus area of triangle, this is our triangle. If we will minus or subtract that one, we have the remaining of this one. And that one is the area of our segment. Again, in finding the area of a segment, we need first the difference of the area of a sector and the area of our triangle. Okay, with that, let us try to answer this example. For example, number 3, find the area of the segment shown in the figure. So this one, the shaded part, this one. And with this figure, we have the radius of 12. So if OA is the radius of this circle, and OD is also the radius of the circle. So if OE is 12, meaning OD is also 12. So this is also 12. And as you can also observe, we have the given of 60 degree, this one. And if OA is 12 and OD is 12, meaning angle D is equal to angle E. Angle E and angle D is equal. And as you can observe, this triangle, diba, we have this triangle. And what is the sum of the interior angle of a triangle? It is 180. So if this is 60, and we have the remaining of two angles, so 180 minus 60 is 120 degree. The total of the angle of these two angles is 120 degree. And take note that angle E and angle D is equal. That's why we'll just divide 120 by 2, it would be 60 degree. If this is 60 degree, and this is also 60 degree, and this is also 60 degree. In that case, we have an equilateral triangle because of all of their angles are equal, which is 60 degree. And we already know that an equilateral triangle is that all of their angle is equal, the same with their sides. Meaning if this is 12, this is 12, this one is also 12. So we have a triangle of an equilateral triangle. Again, let us go back to the area of a segment. In finding the area of a segment, we have this formula. Okay, let us try to find first the area of a sector. What is the area of a sector, Gani? Diba, in finding the area of a sector, we have this formula. Theta all over 360 times pi r squared. Diba? This is the formula in finding the area of a sector. And what is the area of a triangle? What is the formula in finding the area of triangle? ganito, it is 1/2 times base times height. Now let us try first the area of a sector. Area of a sector is theta all over 360 times pi r squared. Now let us substitute the value of our theta. What's our theta? It is 60. It is 60 all over 360 times pi. What is our radius? Our radius is 12, so 12 squared. And if we will lowest term 60 all over 360, it would be 1 over 6, right? Because we divide numerator and denominator by 60. Times pi r squared or pi 12 squared. What is 12 squared? It is 144. 144 times pi, it is 144 pi. What is 1 over 6 times 144 pi? It is 24 pi. The 24 pi is the area of our sector. Okay, we already get the area of the sector, this one. Next, we will try to find the area of a triangle with this formula, 1/2 times base times height. 1/2 base times height. Since we have this triangle, the equilateral triangle, this one, ED is this one, this. Diba, in finding the area of triangle, it is 1/2 times base times height. And this is our base, this one, or this one, times our height, this one, or this one. Divide this is 60, and if we divide 60, it would be 30 and 30. And this is also 60, 60, and 60, meaning 30, 60, 90. And 30, 60, 90 triangle is a special right triangle. And as we can observe, diba, 1/2 base times height, do we have the value of our base na? Yes, we have the value of our base, which is 12, this one. 6 plus 6, 12. We also have the value of our base, which is 12. Our problem is that, do we have our height? No, we don't have the measurement of our height, this one. And for us to solve that one, we can use, or we can solve our height with the help of the Pythagorean Theorem, this one. So our height here is our longer side. So our height, this one, this is our height. Oh no. This is our height. This is our C, because this is our hypotenuse. Our height or our B. Our height or our B or our longer side. This one is our A, because this is our shorter side. Diba? In Pythagorean Theorem, C squared is equal to A squared plus B squared. Since we're looking for the B, so it would be H. Since we're looking for our height or our base, since we're looking for, diba, we have this formula in Pythagorean Theorem. C squared is equal to A squared plus B squared. C is our hypotenuse, A is our shorter side, and B is our longer side or our height there in the figure. With that, if we're looking for the B, we have the formula of B squared is equal to C squared minus a squared, diba? So b squared, do we have the value of our c or our hypotenuse? Yes, we have this one, 12. So 12 squared minus a squared, do we have our value of a? This one, which is 6. Yes, we have. So 6 squared. b squared, what is 12 squared minus 6 squared? It is 108. And for us to find the for us to find 12 squared minus 6 squared is 108. 12 squared minus 6 squared is 108. And for us to find the value of b, we will get the square root on both sides. b is equal to square root of 108 is 6 square root of 3. Again, our base here is also our height. Aside from using of Pythagorean Theorem in finding our height, we can also use the 30, 60, 90 special right triangle theorem, where if this is our triangle, this is 30, this one 30, and this is 60. Wait. This is 60, this is 30, and this is 90. So 30, 60, 90 is a special right triangle. And based on the 30, 60, 90 special right triangle, we let the side of the 30 degree, we let that as x. The opposite side of 30 degree, we let that as x. This is based on the 30, 60, 90 special right triangle, And for the c, we let that one as 2x. We let our c as 2x. And our b, or the opposite side of 60 degree, we let that as x square root of 3. Again, based on 30, 60, 90 special right triangle, the side of the angle opposite of 30 degree, we let that one as x, this one, and the side of the opposite of 60 degree, we let that one as x squared of 3, opposite of 60 degree, diba? This one is its opposite side, or the x squared of 3, and the hypotenuse, we let that one as 2x. And if this is our figure, we have the value of our c, which is 12. And our x here, this one, which is equal to this one, which is x. And our x here is 6. If our x is 6, then our hypotenuse is 2x. So 6 since 2x, so 2 times 6 is 12. So our hypotenuse is 12, which is the same with here. And for us to find this one, our height is, we can use this formula, x squared of 3. And we already know the value of our x, which is 6. Meaning, x squared of 3 is, what is our value of x? It is 6. Again, what is the value of our x? It is 6. Then square root of 3. Then, we have now the value of our height, or our longer side, which is 6 square root of 3. Again, We can get the value of our height with the use of Pythagorean Theorem in this way, or you can use the 30, 60, 90 special right triangle na concept. Because if you know the 30, 60, 90 special right triangle concept, you don't need to go through in this process. You can just solve the height with this, diba? We don't need to solve with this way. You can just type, you can just input the value of our x, which is 16. We can automatically have the value of our height, which is 6 square root of 3. Aside from using a Pythagorean theorem or 30, 60, 90 special right triangle, you can also use the trigonometric ratio or the sine, cosine, tangent, like that. Okay. So far with that, let us go back with this in finding the area of a triangle. Then, do we have the value of our base now? Yes, we have, which is 12, because this is our 12. This is our base. 6 plus 6 is 12. So that is our base. Yes, we also have now the value of our base. Next, do we have the value of our height na? Yes, we have the value of our height is 1 or this 1. Since we also have the value of our base and also now the value of our height, next we will just substitute that 1. Okay, 1/2. What is the measurement of our base? It is 12 because 6 plus 6 is 12. What is the measurement of our height or our longer side? It is 6 square root of 6 square root of 3. 1/2 times 12 times 6 square root of 3, it is 36 square root of 3. So the area of this triangle, this one, this triangle is 36 square root of 3. Again, let's go back to the formula. In finding the area of a segment, we need to find the area of a sector and area of triangle. Yes, we have now the value of our area of sector, which is 24 pi, and the area of a triangle, which is 36 square root of 3. Then area of segment of our segment is equal to area of a sector. What is the area of a sector? It is 24 pi, 24, right? 24 pi, right? This one. Minus area of a triangle. What is the measurement of the area of a triangle? It is 36 square root of 3. With this, we have the area of our segment, which is 24 pi minus 36 square root of 3. In decimal, it is approximately 24 pi minus 36 square root of 3. It is approximately 13.04. So that's it for finding the area of a segment. Okay. So if we have questions in finding the area of a segment, you can drop your questions in the comment box. So that's it for finding the area of the segment. Thank you and God bless.